What happens when a structure fails before the material even breaks? That's buckling. In this video, we use Creo Simulate to understand buckling behavior and the buckling load factor. First, we run a static analysis in order to perform a buckling analysis. Then, we evaluate the buckling load factor to see how close the structure is to instability. If the buckling load factor is between 0 and 1, the structure will buckle under the applied load. Finally, we change the geometry and see how it affects the buckling load factor and the construction's stability. Let's say that you have the following geometry. Modeling this, it's not that complicated. You can model something like that. And you have 3 separate bodies. Make sure when you extrude, you have 3 separate bodies. Then you go to Creo Simulate, and first you need to do a static study in order to do a buckling analysis. You apply a load here, say minus 1 kilonewtons downward here, and you fix this end, and you apply material to the steel low carbon with the following tensile yield strength, and you do the quick study. New static. You call this static analysis from static, and you run this. And you go to results, and you can see it's almost halfway there. So the safety factor is somewhere around 2. And let's see the buckling load factor, or let's do a buckling analysis. You can call it buckling, and you can do a single pass adaptive or multi-pass adaptive, but let me just do a single pass adaptive. It doesn't really matter for our case. And you can filter a negative buckling loads if the construction is somehow will buckle under tension. But in our case, we are going to study this and this body is under compression. We can filter this, and we can run the study. And look at the buckling load factor is almost, it's good. It's not going to buckle. It's more than 1, so it's safe. It's 2.67, and you can see deformed. Let me just. You can see it will buckle like this. So if we do this part a little bit more thicker, it will. This is 10 millimeters, but this middle body is 5 millimeters. So maybe if we do this, when you change it, you need to go out from the simulation. 5. If you do it 10-2, maybe this will affect the buckling load factor. But first we need to do the static study, and then run the buckling load factor, the buckling analysis, and see the buckling load factor. If it's 2.6467 or not run it. No. Just show the results. And it's 19.4, so it's better if you do it a little bit thicker in the middle. And obviously if you move it down, 19 becomes even more. So maybe let's do that. 115 becomes 210, say. And let's do a simulation. This is my shortcut to simulation. Static, let's do a static first. And then run this. And look at the results. 19 becomes 24, so even more safe when it comes to buckling. But let me just open what was it called? Analysis 1 static. And this is the static. And the safety factor is maybe 2 here, and it's 24 when it comes to buckling. But before that, it was something else. So this is how you improve the construction, the design with buckling analysis. You change the geometry to your advantage and do the buckling analysis and see and look at the buckling load factor. You need to have a buckling load factor more than 1, preferably more than 5, but it depends on the application. So yeah, I hope you learned something, and don't forget to like and subscribe if you like the video. Thank you.